Welcome to the ET335 SR Latch lab demonstration. This is the short version where I'm assuming that you have a good handle on multisim. There will be a longer version where I do the entire assignment. Okay, here's our shortened version, and I'm just going to show you where to select the components. I'm also going to give you this file so that you could go ahead have the one that's got the components. So the first thing we're going to get is we're going to get 74 LS, and we need to grab NAND gate. We're going to do A. Okay, let's make them big, and let's grab a 7402 A. Let's go ahead and cancel out and make these large so we can see them. Good. So there's our two gates. I use the LS, and we're going to go to our power, and we're going to need VCC, which is 5 volts, and it's saying that we have internal voltages, which is good, and we need a ground. Okay, so we're going to go back to basics. Let's go back and get a resistor. We're going to need I think a 1K and a 470, and we may not even need the 1K at that. I can't. Alrighty, so let's grab some. Let's go here to indicator, and let's grab a red probe. That's pretty enough, and let's grab a LED. So we're going to go to diodes. LED, let's get a red, and let's get a green. Okay, these should work with our resistors. Blues and some other ones, sometimes a current source. So what you do is double click on it and go ahead and reduce this current. Instead of changing resistors, just go ahead and turn down our on current, and that should get the LED to work if you have an issue. Up, and we need a switch. And switch, and we want a SBDT. Okay, and if you need to change sides, just go ahead and flip horizontally. Yeah, that looks good. Here I have a multi-sim diagram that's complete. It's an SR latch, and it's based on a 7400, which is a NAND gate. So this one is going to demonstrate the truth table. So I'm going to go ahead. I have A as one of our inputs. Let's turn it on. And I have A as an input. And our light will come on when it's high. And I have B input. And again, our probe will turn on when it's high. So let's start with our truth table here. So here we have low, low, and we're going to get a high out. So this one is sourcing, and our lower LEDs on. So let's try 0, 1. Okay, 0, 1. We're also getting a high. Okay, so let's try 1, 0. Okay, 1, 0, and we're also getting a high. So let's try 1, 1. And 1, 1, which is our unique condition, 1, 1 equals 0. So we have this one sinking, and it's a 0. So that's our NAND gate. Here we have our SR latch for a NOR gate. And again, what I've used is our SPDT switch. And I have VCC and ground, so I could operate this switch in either direction, and it'll give us a high or low. We have probes here which are going to light up when it's a high, and I have my little LED totem pole which is going to tell me if we have a high or low out. So let's start it, and let's go ahead and go through the truth table. So let's go start at 0, 0 and B 0, 0. Okay, so truth table 0, 0 is going to be a 1. This is sourcing, it's providing voltage to our LED. So that's a 1. That's our unique condition. So let's try 0, 1, and it is a low. So we have sinking here, and we're providing a ground for our LED. So let's try 1, 0. It's also low. Okay, so let's try a high, high. And that's also a low. So when we go to 0, 0, that's our unique condition, and we get a high. Here I have a debounce switch made from NAND gate 7400. And this one is going to be an active low device. So we have pull-up resistors here, so we're going to put 5 volts on these. I have a 1K pull-up, and we have an output LED with a 470 ohm resistor, and I've got this set up for the key. And since it's a low, I'm putting a ground on our switch, and we have input highs that when the switch is in between, it's going to be no change, and when it goes, it's going to latch. So let's go ahead and try it. So right now we have a reset, we have a set, and you notice that it changes quickly, and this is what we're going to use to prevent switch bounce on a lot of our circuits that we're going to make. Okay, here's our debounce switch made from 7402s, which are NOR gates. And NOR gate, these are active high gates in a debounce, so we need to use pull down. So I have 1K to ground, 1K to ground. Alright, so when the switch is in between positions, it's in a no change condition. So here we have a high because it's an active high. So let's try it. And we're using a space bar for switch. Here I have a latch, which is a set, and a reset. Set, reset. So this debounce switch works. They both work. They just need a different set of resistors in and switches.